All right, what we have to do now is find the derivative of this function using the definition of the derivative. Now, this is never fun, okay? It is never good to find the derivative using the definition of the derivative. It's always a big, hard slog. That's why I've got so much empty space. But remember that the definition is always the same. It's the limit as h goes to 0 of f of x plus h minus f of x divided by h. So the way that that will apply to this is we're going to take this function, put x plus h into it, subtract the normal version of it, divide it by h. Hopefully we'll be able to come up with something cool based on it being like, based on it being already a fraction, because this limit definition is itself a fraction. But, you know, we'll do what we can. I'm going to just write the algebraic version of the thing we're taking the limit of, so I don't have to write like lim every time. So I'll say f of x plus h minus f of x over h. What does that end up being? Well, it is 3 plus x plus h over 1 minus 3 times, be careful, use parentheses there because it is the quantity, x plus h, and that is the x plus h version, then minus the normal f of x version, 3 plus x over 1 minus 3x, and this whole big thing over h. This is every bit as bad as it seems. So we are going to need to do some pretty serious manipulation here. 3 plus x plus h over 1 minus 3x minus 3h minus 3 plus x over 1 minus 3x, and then that whole big thing over h. Well, I'm thinking like, should we form a common denominator between the top two, or should we try to take the h in from the start? I think we should probably form a common denominator, as horrible as that is. So I'm going to do this. It'll have to be times 1 minus 3x over 1 minus 3x. There is no way to form a simple common denominator there. Like, they don't have anything secretly in common because of the 1 minus 3x. That's just like almost cosmetic. So 1 minus 3x minus 3h and 1 minus 3x minus 3h. Hold on, this is going to be a rough ride. 3 plus x plus h. We're going to do multiplications like this. Boom, boom, boom. So 1 times 3 is 3. 1 times x is x. 1 times h is h. Minus 3x times 3 is minus 9x. And then times x is minus 3x squared. Times h is minus 3hx. On the bottom, 1 times 1 is 1. Then minus 3x. Then minus 3h. Then minus 3x. Then plus 9x squared. Then plus 9hx. And unfortunately, we're going to have something just as complicated on the other side. Minus, and here I mean to copy this minus sign so that I don't have to worry about reversing things just yet. So minus, and then all the multiplications will be 3 minus 9x minus 9h. That's just multiplying by this. And then I'll do all the multiplications by the x. It'll be plus x minus 3x squared minus 3hx all over. And now here I'm gonna combine them. Well, really, it will end up being the same as before. But in case, like, maybe it'll end up being more convenient to actually have them still factored. So I'll write them factored in that form. That whole big ugly horribleness over h. And now, hopefully, we're going to get a little bit of payoff. Like, now, this is usually the step where things start to cancel. So let's do that. Let's say, okay, knowing that this minus sign is the thing that links the two, what I'm looking for is the same thing to show up in the first fraction as in the second fraction. So 3 minus 3, those are gone. And then negative 9x minus 9x, those are also gone. Negative 3x squared minus negative 3x squared, those are gone. Oh, gee, it's almost everything, actually. X minus x, that's gone. And negative 3hx minus negative 3hx, those are gone. Does anything survive this? Well, it looks like I have the, that didn't cross off. I've got 3 and 3, those are gone. X and x, those are gone. Negative 9x and negative 9x, those are gone. Negative 3x squared, that's gone. Negative 3hx, that's gone. So the only thing left over is the h and the negative 9h here. So that ends up being h minus negative 9h. That's h plus 9h. So that's 10h. Don't you just love canceling? It got so much easier. And then that's going to be divided by, you know what? After writing both versions, I think that this probably does look like it's going to be the winner. Maybe. We'll see. We'll see. It'll be divided by, I'm going to bring the h into the denominator, because after all, I'm dividing by it. So really, this will end up being h, by which I mean this, that those two are the same. That'll be times 1 minus 3x times 1 minus 3x minus 3h. And now the magic happens, right? Because the goal in getting a derivative by the limit definition is usually to get the h on the bottom to disappear. And now we can do it, because now, boop, boop, those are gone, because now it's a factor of the top and the bottom. So now we can say f prime of x equals the limit as h goes to 0 of 10 over 1 minus 3x times 1 minus 3x minus 3h. And looky, looky, there's no h on the bottom, so it's not going to go to 0 anymore. This goes to 0, but everything else is left alone. So it's going to be 10 over, and as a little bonus, this and this are actually going to end up being the same. So we don't even have to write two factors on the bottom. We can write 10 over 1 minus 3x squared. And that right there is a nice big juicy derivative. Cool, huh?